We are going to be solving LeetCode problem 1302, deepest leave sum. So you are given a binary tree and you have to return the values of its deepest leaves. So in this case, at the deepest level, we have the node 7 and 8. So you have to return its sum. Its sum is 15, so you have to return 15. So there could be anything at its deepest level. So notice one thing, that we are not considering phi. So it's actually we have to consider a level, not just leaf nodes. So if you only consider a leaf node, you may get a wrong answer. So there is kind of mistake in the problem if you read it carefully. So never mind that. So let's take a look at its solution. So first thing we are going to do is find the height of the tree. You can also solve this with using Q, the breadth first search, but we are going to do depth first search. So we are going to do this recursively. So first thing you are going to do is find the height of the tree. So if you don't know how to find the height of the tree, it's pretty easy. I could have explained it, but it will go off topic. But if you see its code, it's pretty easy, just 2 lines of codes. So first we find the height of the tree, so which is 4 in this case. So what we are going to do next is we are going to initialize a global variable and assign it value 0, so it will be our answer. So as we travel the tree recursively, we are going to update this variable. So the next thing, we are going to make our recursive function, which will take parameters root of the tree, the height, and the CW variable, which just indicates that at what level we are. So remember, when we find height of the tree, so we have to return the sum of the values of nodes of whatever height we have just discovered of the tree. So we are going to keep track of the height of the tree as we traverse recursively, and whenever we encounter a height of 4 which we just found, then we are going to add the value of node, whatever node we found at that level. So we first make call at the root. So root and height will always be the 4, and CW is equal to 1, which is indicating that we are at first level. So we make our next call. Remember, now we have updated the CW variable 2, which indicates that now we are at second level. So we will this continuously and make recursive calls on our tree. So now CW is 3 and now 4. So we are at the deepest level, which means we have encountered a node which is at the height of the binary tree, which means it is at the deepest level. So whenever the height and the CW variables are equal, we are just going to update our sum variable with whichever value we found at that node. So in this case we found 7, so we are just going to add 7 to our sum variable. So now our sum variable is 7, and we are continuously going to call our function recursively. So we make 2, we make 3, and now we again encounter our node where CW is 4. So we are again going to update the sums value and add 8 to it. So now our sum is 15, which is our answer. And whenever we complete our traversal, we are just going to return the sum. So now let's take a look at its code. We will start by declaring a global variable of sum, or let's just call it answer. So it will be 0 initially. So we are getting root in this function. So first thing we need to do is to find the height of the tree. So let's just call it h and make a function fh, which means find height, and pass the root to it. So let's just quickly define the fh thing. So it will be returning in fh and it will take tree node. So tree node star, let's call it root. So our base case will be if root is null. So if not root, we will just return 0, and we will return max of fh of root of left and fh of root of right. right plus 1. So that's how you find the height of a binary tree. So now we will make our solve function. So we will pass it root, we will pass it the height, and that's it. And after that we'll finally return the answer, So let's code this solve function. So it will be a void function solve. It will take tree node root. Let's take it by reference. We will also take the height by reference, and we will make a CW variable which will be 1 initially, and our base case will be similar. So if root is null, so we will just return, and our another condition will be that if height is equal to the CW variable, which means that we have we are at whatever height we have found. So if h equals CW, what we will do is we will update our sum variable. So sum plus equals whatever the value of root is. So value of root, actually value, and that's it, and then we will return. So now we just need to make call to our left subtree and right subtree. So we'll first check if there is anything at left or right. So if there is anything at roots left, then and only then we will call it for the left. So we will call it for roots left, and we will give the same height, and here we will give CW plus 1, which means we are going to the next table, and we will do the same thing for right subtree. So if there is anything at the right of the tree, we will call solve for right of the tree, roots right, and we will pass the same height, and here also we will update our CW variable, indicating that we are moving to next level. So I think that's pretty much it. Let's see if it works. Let's see, there is some error. So it's not sum, it's actually answer. Right, let's run it again. So it works. Let's just run on this test case as well. Let me just copy it and paste right here. So it works perfect. Let's just submit it. Yes, it works faster than 27% of submissions, which is pretty decent. So I hope you understand the problem as well as solution.